Explain the video goal and say this will cover what a loader ship is, the different types and roles, high-level design and naval architecture concepts, major systems and cargo handling equipment, the shipbuilding and procurement process, testing and certification, operational considerations, safety and environmental rules, and recommended learning paths for engineers and ship operators. Give a simple definition of a loader ship in plain terms, a vessel designed to receive, carry, and transfer large volumes of bulk or containerized cargo, often fitted with specialized equipment for loading and unloading at ports, offshore terminals, or transfer points. Mention examples such as bulk carriers, transshipment feeders, self-loading barges, and shuttle vessels used in ports, mines, and offshore terminals. Describe concept and requirements at a high level. Define mission profile, cargo type and density, cargo handling method, required payload, transit distances, operating waters and climates, port infrastructure constraints, speed and endurance targets, draft and beam limits for intended ports, and commercial and regulatory requirements. Emphasize matching ship form and equipment to intended use rather than one size fits all. Introduce basic naval architecture concepts without technical detail. Explain hull form and how it affects resistance, seakeeping and cargo capacity. Describe stability and intact and damaged stability concepts conceptually, and why center of gravity, metacentric height and freeboard matter. Mention structural strength and Scantling principles at a high level and why structural design is critical for safe cargo carriage. Outline major systems and subsystems conceptually. Propulsion and power generation options for the vessel including main engines, auxiliary generators and shaft or pod-driven arrangements. Cargo handling systems such as cranes, conveyors, grabs, conveyor belts, hatches and self-unloading booms for bulk cargo. Deck and cargo hold layout including hatch sizes and access. Ballast and trim systems for stability control. Steering, mooring and deck machinery. HVAC, accommodation and habitability systems for crew. Bridge and navigation suite and basic automation systems. Describe cargo handling options conceptually. Compare shore-based loading with self-loading/self-unloading arrangements. Explain conveyor and grab systems, deck cranes and gantries, belt conveyors and continuous unloaders, and roll-on/roll-off arrangements for specialized cargo. Discuss trade-offs, speed of operations, crew requirements, maintenance, and compatibility with port infrastructure. Explain testing, trials, and certification in general terms. Dock trials and harbor checks for systems integration, followed by sea trials to verify speed, maneuvering, endurance, and safety systems. Classification society surveys for structural, machinery, and safety compliance. Documentation and statutory certification for safety, load lines, tonnage, and crew certification as required by flag state and international conventions. Cover regulatory, safety and environmental topics at a high level. Mention international conventions like SOLAS, MARPOL, coal regs, and ballast water management without legal advice. Discuss emissions controls, fuel choices and options to meet IMO rules, ballast water treatment, garbage and sewage management, and noise and vibration considerations. Stress the importance of safety management systems, crew training, life-saving and firefighting equipment, and planned maintenance regimes. Mention quality assurance, inspection and maintenance in general terms. Planned dry dock intervals, hull inspections, structural monitoring, condition-based maintenance for engines and cranes, non-destructive testing by certified surveyors and record-keeping for certificates and warranties. Summarize the core ideas. Making a loader ship is a multidisciplinary effort involving naval architecture, structural engineering, machinery and cargo handling systems, shipyard planning, regulatory compliance and commercial planning. Emphasize that design and construction are carried out by teams of trained professionals, classification societies and certified shipyards, not as DIY projects. Visual suggestions for the video input. Show concept sketches and animated hull forms morphing to show hull capacity versus resistance trade-offs. Show labeled cutaway illustrations highlighting cargo holds, conveyor routes, cranes and ballast tanks. Show animations comparing shore-based loading versus self-unloading conveyor or boom systems. Show footage of block assembly, a shipyard, outfitting of cranes and deck machinery, and dockside trials in a non-operational explanatory context. Show overlays explaining SOLAS MARPOL and ballast water concerns and highlight crew training and safety drills. End with a call to action to study marine engineering and naval architecture courses, engage with shipyards and classification societies, and pursue formal training for any hands-on shipbuilding work. Use this full script as the video input for Pictory.ai to generate an educational explainer about designing, procuring, and bringing a loader ship into service while emphasizing safety, regulation, and professional practice.